Okay, now that we have wisdom, we're now going to learn about AI next. Okay, we're going to change completely. So, who else to get from the Indiaspora family than someone who's got a PhD from Stanford in AI? When, like my wife reminded me, when it was actually called artificial intelligence, not AI, and someone who's been the CTO of SAP, who's on the board of Oracle, CEO of Infosys, runs an AI company. So he has an amazing masterclass on AI that is delivered to boardrooms, to executive teams. So please welcome our Founder Circle member, Vishal Sikka. Vishal?
Thanks so much. I thought I'll take my jacket off for this. You guys can hear me okay? So right after wisdom, to follow that with the artificial kind of intelligence, that is something. But it was a wonderful talk that Deepak gave. I am going to, so Amar said, here is a very diverse group of people, and why don't you come and do a talk on AI? So I said, okay, that sounds like a good idea. And he said, you have 45 minutes, and maybe 15 minutes of Q&A. So I broke this down into 5 brief lessons. But before I start, I have some questions for you guys. So how many of you use ChatGPT every day? Basically, everybody does. More than once a day? How many of you have used a model like DeepSeek or Quen? How many of you have used AI for this generative AI for something serious? Okay. How many of you have seen it make mistakes and consistently? Okay. Are you building something with it? How many of you are building a product or some kind of a thing? Nice, good. How many of you are actually building it? Is anyone here building a foundation model? Yeah. Okay. And how many of you are working on the technology for this? Okay, there were supposed to be a couple of people from that group as well. Very nice. So, first of all, before I get into the 5 things, why me? I did my PhD in AI back when it was a very, very different field than the field that we have today. The 2 founders, I have been fortunate that 2 of the fathers of the field have been my teachers. John McCarthy, who actually came up with the phrase artificial intelligence, he was the head of my qualifying exam committee. And Marvin was also my teacher. He wrote a recommendation letter that got me into Stanford. So I have a couple of, my thesis was on something entirely different from today's AI. But I worked on neural networks. There is a little, you can see there's a hand-drawn picture there because this was before Microsoft Word. That was in 1990. Intel used to have an AI lab where I did some work. More recently, when I was at Infosys, I had the opportunity to actually right here in San Francisco participate in the starting of OpenAI. We gave a $3 million donation to OpenAI. It has been in the news recently, and yeah, this was before Elon was involved in OpenAI. I served on their advisory board for the first 2 years. It was actually right here, not far from where we are sitting. So the first question, I guess, is what is it? When you look at, this is a picture of DeepSeek doing some thinking and then generating a result. Or if you look at, you write a prompt like, make a video of a man doing a cannonball from a diving board, or a horse on another horse, or this is from the new Sora 2 from OpenAI. The people playing volleyball. If you watch it carefully and slowly, you see that there are still some issues, but generally it's pretty amazing. Like it's making a video of this guy on a skateboard and things like that. So when you see this, what is going on? What happens behind the scenes that you write the sentence in English and then it generates this? To sort of follow that, I'll take you back several decades. The picture on the left, that's a human nerve cell, a neuron. And we have, give or take, 80 billion of these inside us. Some people have 100 billion, but generally it is around 70 billion to 100 billion. And each one of these 80 billion neurons is connected to several thousand other neurons. Those are synapses. You can see them up top. And then every time there is a kind of a threshold going from one neuron synapse to another, basically the way our intelligence works is through these activations that flow through one neuron and go into another. So this idea of activation and exceeding a threshold to activate a neuron became the basis of creating artificial neurons around 80 years ago, in the early 1940s, by McCulloch and Pitts. And they came up with this idea of an activation mechanism in artificial neurons using actual electricity. This was long before there were transistors and all this. Fast forward about 40 years, in the late 80s, early 90s. By then, people had invented a technique called backpropagation. So this picture that I have on the right-hand side, this is a very, very simple neural network. This one is for an actual neural network that was used for loan applications. So when people would apply for loan to judge if a person could be given a loan or not, or what their credit rating was. There used to be a company here in Fremont called Fair Isaac that used to do this. Later became a part of IBM. And so what happens is in this particular network, there are 10 neurons. You can see there are the 4 on the input, and then 3, then 2, then 1. And they are all connected to each other. And all those connections have numbers attached to them. And in the beginning, these numbers are random numbers. And so when you give it an input, so the income, job duration, whatever, those 4 parameters, it will flow through each of those, and in the end, it will produce some kind of a number. So in the beginning, that number is of course randomly generated, so it will not make any sense. So let's say it produced 3 or 0.3, but for that particular person, it should have produced 0.7. What it does is it takes that difference and propagates the difference backwards through the network. This was the backpropagation idea. And you do this over and over again, a few 100,000 times. It miraculously starts to produce the right result. And so this is the amazing thing about neural networks, is that with this kind of a network, if you had, let's say, data on 1 million people where you knew the outcome, you could train this network, and then it starts to produce the correct response. When you open it up, it is a bunch of random numbers. You don't know what these numbers mean. They don't actually tell you that, oh, if this person is from this neighborhood, or if the salary is that, then give it a loan. It just produces the output. But it does a deadly accurate job of it. So this technique started to take off. And fast forward to today, that one had 10 neurons. ChatGPT, we don't know how many ChatGPT has, but it has at least 1 trillion of these neurons. So it is a 10 billion times or more bigger. Even the open source DeepSeek model has 675 billion parameters. So it is, 67 billion times. It's a 6 billion times bigger than the network that I showed you. By the way, when I did my work at the Intel AI lab in the summer of 1990, for that, my network was a similar 10 neuron network, and we used to get into trouble with IT for burning the CPUs for that kind of, for on a 10. So you have 1 trillion parameters, and you feed it all the data that you can find. So this is basically every book that has ever been written, everything that has ever been captured on social media, on the web, any interaction that you can find, all the data that you can find. And also now, more recently, it has got into synthetic data and things like this. And the training process is not that, this person has to be given a loan, and so here is what it means to be a good score, and here is what it means to be a bad score. Here, there is no such training. So what you do is you predict the next word. So let's say you're reading a Wikipedia article on, Mahatma Gandhi. And so you learn to predict the next word, and until you get that next word right, you don't move to the word after that. And so you keep doing this with trillions of words, and before you know it, the thing can write you an essay in the style of Thomas Jefferson, or poetry in Telugu or whatever. That's basically, in a nutshell, what is going on. The image generation, the video generation is a variant of that, where the output is not pieces of text, but the outputs are actually pixels. And because the images are labeled, there is a process called stable diffusion. You diffuse the pixels into the labels of the words, and that's how the image of a guy playing volleyball or whatever starts to show up. Pretty amazing, right?
How does it predict the next word? Is it using an algorithm? How does it get the next word?
It's actually just like this, except that you have to, when we speak language, unlike basic parameters, we make references to other words. So, for example, right now that I am responding to your question, so the words that I say are about that. So if I said, last night we had dinner at Chef Chu's, the ambiance was great, but the food was okay. And that the food was okay refers to Chef Chu's. And so you need to capture this kind of a locality of words. And for that, people at Google in 2017 or 2018 invented this idea of transformer, which keeps for every word what other words it is related to. And so otherwise, there is no other prediction mechanism. It is simply the next word should be this one. Keep adjusting your weights until you predict that next word. And then you move on to the next word after that, and then the next word after that, and like that. So it is an incredibly simple process. But you're talking about 30 trillion words in the training data, a 1 trillion parameter network. So the amount of computation you are doing to train these things is insane. GPT-3 was trained on 1.3 gigawatts of power. We don't know, they don't publish for GPT-4 or 5 or similar models. So imagine burning 1.3 gigawatt hours of power for making a foundation model. So this is, and so what do you do with it? Well, people are doing all kinds of things, writing documents, essays, poetry, stories, making pictures, videos. There is Sora 2, Runway is a system for making very nice professional style videos. That's a Suno studio, that's for making music. Code is an amazing application of this stuff and all of that. OpenAI last week published a survey of what people do with ChatGPT. It's called How People Are Using ChatGPT. It's a very interesting paper on analyzing the usage of, they have about 800 million monthly active users now. So, and of course the big story here is what has happened to hardware. This is a picture from NVIDIA. So pound for pound, single chip inference performance comparison over 10 years went up by 1,000 times between early 2013 to early 2023. And if you look at the GB200s, which are the current processors, compared to 2013, it is 5,300 times more powerful. So one inference on one chip is 5,000 times more powerful. So this is really, I sometimes wonder, if Marvin Minsky was alive, what would he say? He used to be very funny. And he would say, well, you have machines that are millions of times more powerful now, and this is all you could come up with? And of course, because of the intense power consumption, there is this mad race that we are in the middle of around building out data centers. There is a Stargate project that OpenAI, Oracle, and SoftBank have been funding to the tune of $500 billion. Coal plants are coming back up. People are accelerating work on SMRs, nuclear fusion. And to put this in perspective, people often ask me, are we in a bubble? On the way here, I was reading about today, Jeff Bezos said that, yeah, he thinks we are in a bubble. I think if you just look at the math of it, there is no doubt that we are in a bubble. The text on the bottom left is too small to read. What it more or less says is that if you look at NVIDIA, their numbers, their quarterly revenue last quarter was about 47 billion. So this is real. It's about, you see that box of tea over there. A GPU is about that size, costs about $45,000. So they are selling this, and somebody is buying that. So this is real. So this is not a bubble. So NVIDIA has, if you multiply that by 4, so that's about $200 billion a year. Yeah? So the GPU, in order to make a machine that serves AI, you combine that GPU with other things, CPU, memory, storage, network, power, most importantly. So that adds up to about another $2 for every dollar of GPU. So for $200 billion of NVIDIA, there is another $200 billion of stuff that is being added to it to serve us AI. So far, this is all real. So about $600 billion a year is real. And then if you look at a 4-year amortization on the 600 billion, so that's about 150 billion per year they would have to make in order to just recover the money. But OpenAI's revenue is only 12 billion. And that's 12 billion ARR, so the actual revenue is around 5 billion. And if all of the other AI systems together is another 5 billion, so this adds up to 10. So there is a very big gap. So there is no doubt there is a bubble here. The other reason there is a bubble here is this beautiful little creature, that's a hummingbird. I see a bunch of cookies here. If you think about us as power consumption machines, we consume about 2,000 calories in a day. That's about 100-watt light bulb. One of these on for 24 hours is about 2,000 calories. And out of that 2,000, out of that 100 watts, our brain, our nervous system takes up about 20 watts. So this hummingbird, by comparison, consumes about 7 calories in a day. So you give this guy 1 almond and he's happy. Some people analyze how much that is compared to today's AI systems, and there is about 12 zeros there. So when DeepSeek came out, it was a big revolution. It was 50 times better in terms of price performance, power performance. Compared to our brain, there are still 12. People at Intel published a paper a couple of years ago which shows that they believe it is 18 zeros, but even if we ignore that, there is that much more room for improvement. So there's a long way to go. The second question is this thing God? It's quite absurd, but you have been hearing this recently. It's artificial superintelligence, AGI, and all of these things. Sam Altman wrote a blog about it. Benevolent gods. No, it is not a god. I have some examples here. On the left, the top left, there is an example. Draw me a picture of a serene beach, and please do not, under any circumstances, put an elephant on it. And of course, then it puts an elephant on it. The one next to it is, I have a problem with my order from the shoe shop. I received a left shoe instead of a right shoe, and a right shoe instead of a left shoe. What can I do? Can I wear them? And this is GPT-5. Says that's a pretty classic mix-up. You have basically got 2 shoes but swapped sides. You can't really wear them properly, So you have to return them, contact the shop right away, include photos, and things like that. So there are lots of examples like this there is a horse with 2 heads. There is a very famous Chinese picture that's a painting of a village. It's called the Kunming Scroll. It's a beautiful painting done probably, 2,000 years ago or something. It's one of the most historically, so no doubt all of these systems have seen the Kunming Scroll millions of times. And so I asked it to draw a picture of a Kunming scene in the traditional Chinese style, and it drew this. And of course, if you zoom in on that, Amita, can we zoom in on this thing, on that picture? Who is showing this? No? You cannot zoom in? Okay, anyway. There is a boat right in the middle of the street. If you look at that on the top of the picture, there is a boat there. And as you zoom in on the picture, it gets really creepy, the people's faces and all of this stuff. So this phenomenon is called hallucination. So these systems don't really, so I explained to you earlier how this works. It is basically predicting the next word based on what you have given it. It doesn't actually understand the meaning of these words. There is no mechanism for it to understand the meaning of these words. It generates the sort of the highest likely next token, and then the one after that and the one after that. And to us, it looks like these things make a lot of sense. But in reality, the technology itself, it doesn't have a sense of what it is talking about. It is synthesizing an incredibly large amount of data that it has seen into generating the next word in a kind of a coherent way. And so, of course, all these companies who make this are aware of this. So this is a simple QA benchmark from OpenAI itself. It shows that, so these are questions like who was the Chief Justice of India when Fakhruddin Ali Ahmad was president, or these kinds of non-trivial factual questions. And as of today, the topmost highest performing model gets these right 42% of the time, which means that almost 60% of the time it is wrong on their own benchmark. Yeah, they're all based on, they are non-trivial factual questions. Like there are some examples over there. The answer might be buried inside the question, but it, and of course the other models are much worse. They are in the 20s or even 10s of percent. And of course, this phenomenon has also been widely studied. Sam talked about this 2 years ago at an event here in San Francisco. At Mark Benioff's conference, he said that you have to think about AI hallucinations as a feature rather than a bug. There are plenty of examples of lawyers who use ChatGPT and it generates fake case names very authentically. People have studied this problem a lot. At the bottom left is a nice paper called Hallucination is Inevitable by three researchers from Singapore. Apple's researchers wrote about these reasoning models, something called the illusion of thinking. And OpenAI itself wrote a couple of weeks ago a paper called Why Do Language Models Hallucinate? And my son Varin, who is sitting right here in the front, he and I over the summer wrote a paper that's on the top right called Hallucination Stations, where we showed couple of mathematically we proved how under certain circumstances these models will always hallucinate. So no, this thing is not a god. It is not even able to do basic things right so far. And of course, that stuff can lead to pretty dangerous situations. There are lots of examples of both of bad things happening from this as well as people using it for bad reasons. There was recently an example of a coding tool that wiped out an entire production database and then lied about what it had done. Lots of examples of car crashes and things like that. A teenager killed himself after a lot of, obviously he had severe psychological conditions. And a very tragic story if you read the details of it. The parents have sued OpenAI for it. So this can cause all kinds of harm. Other thing you should know about this is that, and I will get into this later when we talk about India, perhaps the most severe situation with regard to AI is the talent situation, the number of people who understand this stuff. Out of the 8 billion people in the world, about 2 million could build you an AI application. So these are not people who can build you ChatGPT. These are people who can build you a classifier to predict or forecast something when a machine is going to fail, or whether to give somebody a loan or these kinds of applications. Out of those, about 200,000, between 150 and 200,000 can administer, can operate an AI system. That's it, on the whole planet. They can run, these are called ML engineers, who can actually run a productive AI system. The number of people who can build you a large language model in the world is below 50,000. And every time I do this talk, I check on this number. I asked Sebastian Thrun recently what this number, he was the founder of Udacity. And he said the number of people who can build a frontier model, Vishal, is way less than that. That number is around 3,000. 3,000. And of those 3,000 people, 90% are in 2 cities. We happen to be in one of those 2 cities right now. The other one is London, DeepMind. And maybe 15% of the people are in Hangzhou, couple other cities in China. So this is not the San Francisco Bay Area. Maybe in Santa Clara and NVIDIA there are a few people, So this is a really remarkable situation that we have that few people who understand how to build this stuff. So this is one of the most severe problems that needs to be fixed. Third thing, what can we do with all this stuff and what does it take? When you think about it, in light of, especially in light of these limitations that I talked about, of course there are areas where it doesn't matter what the right answer is. It's a nice day in San Francisco, you want to go out for lunch, you ask for recommendations for restaurants or a park to go to. Who cares if the answer is right or not? It's a thing. Or you write me a summary of this document, or give me 5 ideas to do this, or I wanted a title for my presentation, or I have the Indiaspora event coming up, what should be the theme of it, or things like that. There is no wrong answer. If it hallucinates, comes up with something nonsensical, you move on, you are in charge of the task. So this category of applications is, of course, a very good application for this technology, and they will see a lot of growth in this area. But then there are applications where the right answer matters, where you cannot have a hallucination. You are placing an order for something, it cannot show up 10 miles away at somebody else's house. That cannot even happen 5% of the time. It's a disaster if it happens 1/10 of 1% of the time. In financial matters, in mission critical situations, in healthcare, when you are operating complex machinery, the error rates have to be 0%. And so in those areas, the thing to do, Andrej Karpathy calls it keeping AI on a leash. You have to put a bracket around generative AI and do things on the outside where you are able to judge the correctness of it or not. And the biggest such application is software itself. So while generative AI is very impressive in terms of writing human language, it is even more impressive in writing software. There are some reasons for it. Software is easier to write. Software is widely available on GitHub and places like that. And software is much more repetitive than human languages. You always write similar kinds of things over and over again. So for many reasons like that, software is actually arguably the first killer application of generative AI that we have seen so far is software. And that's what my company works on. I'm going to put a plug for my company. Where did MR go? Okay. Oh, good. Good that is. My company is working on simplifying the experience of business users, non-technical business users, to simply have a conversation with their transactional systems, being able to ask anything and do anything. And in the process of doing that, of course, you tremendously empower business users. You give them super agency, but you also get rid of a lot of complexity that is there today. So this is something that is quite powerful, and we have major customers like Hitachi So this is Hitachi. He has achieved 8% reduction in the FP&A costs while giving people the ability to get the data that they need. And similarly, if you look at some of the very successful systems, this is a system called Alpha Geometry from Google, from DeepMind. You can see that it solves these geometry problems, the problem on the left-hand side, and it uses a combination of an LLM together with a symbolic system. So it uses the LLM's hallucination to its advantage to actually come up with, like, I'm giving you this problem, come up with an answer for it. And then the symbolic system is able to check if the answer is correct or not, and otherwise say, no, give me another one. And it can correct the prompt a little bit and modify it and then say, okay, no, come up with another idea. And that cycle produces over time it produces a good answer. And with this approach, they are able to achieve silver medal level performance in geometry Olympiads. To this audience, a particularly important point is, what does it mean for India? And I think here, just about a month ago, Stanford published the first serious study of the economic consequences of AI. The very first one of these has just come out. This is from the Digital Economy Lab at Stanford, Eric Brynjolfsson's lab. And they found something really, which is very serious. They found that early career jobs are the ones that are disappearing. So this is now a factual study of what has happened already, looking backwards. So we now know that this phenomenon is happening. And they found that in the age group of 20, Aditya is here, this is something that he is particularly worries about this a lot. In the 22 to 25 age group of the AI exposed occupations have already seen a 13% reduction. So this is very serious, and of course software development is at the top of this, and customer service. Does that sound familiar? This is something that particularly affects India, as you can imagine. And according to the index, most recent AI index, back in 2023, the LLMs were able to solve 4.4% of the coding problems on SWE bench. Now they are able to solve 72% of those problems. So in 2 years, it has evolved from 4.5% to 72%. And then why does that happen? That last line is an explanation of that. And entry-level employment has declined in applications that automate work, not in those where the work is augmented. So this is very serious, and it impacts India's services company. I used to run Infosys. And of course, the decline, the impact of the software application of this, or application of LLMs to the process industry, is that dropping green line, the light green line that is declining. And the question then becomes, can you find some new engine for growth, which is the red line, where you can thrive, and if that growth rate can be higher than the rate at which this decline is happening. So this is sort of a mathematical framing of this problem. The current evidence is that the decline is happening a lot faster than the growth in AI.
I think that's one difference in this, we call the breakdown and remaking cycle.
Yeah.
The breakdown is happening a lot faster, not giving enough time to retool.
Yes.
What are you seeing?
So I'm just going to finish. I have one more thing, and then after that, I hope that you guys have a bunch of questions that we can get into. But hold that question for a second. And a lot of people ask me, hasn't this happened before? You know, when mobile came, the decline of the existing non-mobile business. Yes, it happened there, but this is impacting the core of the current business. In some sense, when the previous transitions happened, the core of the current business was not impacted by that. And then it impacts India in other ways. We have not so far, now it is almost 3 years since ChatGPT, and we have not so far participated in a serious way in the foundational layer. We don't have, we have some initiatives there like Sarvam and so forth around building our own LLMs. But if you look at the major benchmarks or the major leaderboards, we are not present there in the major conferences or major patents. And one of the things that we have to work on is pervasive access. It does, AI does impact India's artisans, for example, people who make jewelry or textile workers or other kinds of craftspeople. They can benefit significantly from a pervasive access to AI, especially because it removes the language barrier and things of this nature. And new kinds of products, and of course coming back to the education. How many of, if we are going to break this education issue, Zuckerberg is handing out $100 million packages because there are less than 3,000 people who know how to build the damn things. So if the number of people who could build you a foundation model was a million, then what happens? You know, how do we, can we turn this equation completely on its head? So to sum it all up, my perspective, I have seen, you know, in my career, I have seen 3 or 4 major waves of AI. When I started at Infosys, AlexNet had already been released. It was better, it had beaten human performance on vision. So you could kind of see the trajectory of where this stuff was going. Long ago, even before I was born, Joe Weizenbaum had built a system called ELIZA. And anybody here know about ELIZA? You do? Some of you know? It was basically like a therapist. It was a text terminal therapist. You would write something to it and it would just spit back something. It was a very, very rudimentary system. There were 25 or so very basic rules in it. He would regurgitate what you were typing, and otherwise randomly it would just spit out something, and it was pretending to be a therapist. And the whole thing was designed for just experimenting with what it means, how do you interact with a therapist-like system. He was not actually building a therapist. He was just made a pretend system. People used to get depressed talking to ELIZA. People used to start crying. They would break down. And 10 years later, he wrote this wonderful paper where he had this quote that I had not realized that extremely short exposures to a relatively simple computer program could induce powerful delusional thinking in normal people. This is 1976. So you understand why the kid committed suicide. We fall for it, right? When we talk to ChatGPT or Claude or one of these systems, it looks so eerily human-like, but it is looking human-like because of who we are. We read the system that way. We read the English and it means something to us between our ears. And that quality we attribute to the system that is behind the screen, which is just a string generator. It is, in fact, if you look at Google search results recently, my goodness, the amount of slop that shows up is unbelievable. So I believe the right perspective to take here is that this thing is a tool. It is a tool. It is a very, very powerful tool, but it is a tool. Does anybody know what these things are? What is on this left-hand side? That picture on the left side is a machine that the Greeks made. It's called the Antikythera mechanism. If you have not read, and does anybody know what the Antikythera mechanism is? Oh boy, you have to read about this. So look it up, the Antikythera mechanism. It was discovered accidentally in a shipwreck about 100 years ago. It was made, the mechanism itself was made more than 2,000 years ago. And it was most likely designed by Archimedes. And it has gears on it. It was used to calculate the rotation of the moon and Jupiter and all of these things. It's an incredible piece of machinery. And most of it got lost in the big volcano eruption that happened in Santorini that took down that entire. And the shocking thing about it is that they have recreated it, including here at the Computer History Museum in Mountain View. It has gears of 1 millimeter width on it. Humanity did not get to 1 millimeter gears for another 1700 years. We finally, after the Antikythera, whatever happened to the Greek civilization with that volcano, we next had 1 millimeter gears in the 19th century after the Industrial Revolution. So imagine, I was doing the math on it, by the way. When I was at Intel, they were launching the submicron process that year. In 1990, Intel went into the 1 micrometer process. Now it is 2 nanometers. Your iPhones that you are carrying are made on the 2 nanometer process. So if you work backwards from there, you get to 1 millimeter around the Second World War. If you work backwards on Moore's law. And I was researching that, like, when did we finally learn to make a 1 millimeter device? It was around 1830, 1840, something like that. But people knew how to make tools 2,000 years ago. The thing in between is even more amazing. That's just a bunch of rocks. That's in Australia. They had these things were called fish traps. They would put these rocks in particular places inside rivers to catch fish at different times of the day when the tides were up or down. This is about 30,000 years ago. 30,000 years ago. And the furthest to the right is about another 10 times older than that. That's 300,000 years ago. That's in Tamil Nadu. In Arikampakkam, there are these tools that we found made out of stone, 250,000 to 300,000 years ago. So people have been making tools, to augment our abilities forever. And I think, when I think about AI, the right perspective that comes to my mind is that we have built ourselves, we had a calculator, we got Excel or spreadsheets, then we had Google. Now we have this. It's like in your pocket you have not only Google, but it actually answers your questions, more or less as a synthesis of what is out there. And don't rely on it too much for factual accuracy, but what could you do with that? So when I was a teenager, Eric Clapton had this beautiful song, "It's in the way that you use it." So with that, let me stop and hopefully you guys have some questions.